Friends, welcome to my YouTube channel. Dhanesh here. Today I am going to discuss about reinforcement learning. Machine learning is classified into three: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. You already know it. See, reinforcement machine learning is a pure form of artificial intelligence. In reinforcement machine learning, we need to understand it's a type of machine learning where an agent learns to behave in an environment by performing actions and seeing the results. See, you need to understand reinforcement machine learning is a type of machine learning where an agent learns to behave in an environment by performing actions and seeing the results. See, agent means, in real life, we human beings are agent. For example, the social laws and the physical laws are the environment for a human being. In the same way, in reinforcement learning, our reinforcement algorithms are the agents. So they have their own environment. When you compare this reinforcement machine learning with other type of machine learnings like supervised machine learning, you need to understand in supervised machine learning, there is a training data set to train the model. But in the case of reinforcement machine learning, the agent or the reinforcement algorithm or the machine learn from experience, not from the training data set. That is one important difference we need to understand in the case of reinforcement machine learning. In the case of supervised machine learning, it is using the training data set to train the model. But in the case of reinforcement machine learning, the agent learned from the experience. So as we discussed, reinforcement machine learning is a pure form of artificial intelligence. Here the agent or machine is used to attain complex objectives. We can tell like reinforcement machine learning is goal-oriented algorithms. Reinforcement machine learning, it is goal-oriented algorithms. You can understand that it is goal-oriented algorithms. This is very important. Another important point, as I told you, here the agent learned from the experience, not by using the training data set. And here, another important point, as I told, for a human being, he is an agent in his real life. So in a particular situation, how he reacts based on that. For example, if he is scoring good marks in an exam, he will be admitted to a good college. Or if you are performing well in your company, you will be promoted. In the same way, it is if you are performing well, you will be getting reward. And if you are not performing well, if you are failing in that, you will be punished. Like that. So the same thing only for an agent, the same thing happens. Here, if the agent is attaining the goals, they are rewarded. And if the agent is not attaining the goals, it is punished. So that is the important point you need to understand. So if the agent is attaining the goals, he is rewarded. Another important point coming here is the reward. Reward is an important aspect. We will discuss in detail all these aspects. See, when you discuss about machine learning models, when we discuss about neural networks or any other machine learning model, supervised machine learning model, we discuss about cost function. We always use the model should be optimized in such a way that the cost function should be minimum. So we always discuss about cost function in the case of supervised machine learning. But in the case of the cost function is also known as objective function or loss function, we call in that way. But the corresponding term coming here is the reward. So here the important aspect, what we need to maximize is the reward. Here we need to maximize the reward. So what is reward? When the agent is attaining his goals, he is rewarded. If he is not performing, if he is not attaining his task, he is punished or penalized. So in the case of cost function, we will always try to minimize the cost function in other machine learning models like supervised machine learning. But in the case of reinforcement machine learning, we always focus on the reward, how the agent is rewarded when he attains his goals. So one important figure I can tell you for this reinforcement machine learning, it is the best figure, perfect figure for you to understand what is reinforcement machine learning. Here you have the agent. This is the agent, and here you have the environment. So I told environment means where the agent is working. So that is his environment. For us, for a human being, I already told the social laws and the physical laws are our environment. For an agent, where exactly he is working, so that is his environment. See, the agent takes an action. Let us assume that it is 80 is the action. So in an environment, it takes an action 80. So if he is attaining the goals, he will be rewarded. That is, he will be getting a reward, that we are taking it as RT, and he will be promoted to a new state, ST plus 1. Here he is promoted to a new state. It is known as ST plus 1. Previously, let us assume that he is in a state ST. If he is failing in his goals, if he is not attaining his goals, he is punished and he will be in the same state ST. He will remain in the state ST. So if he is attaining his goals, he will be rewarded. He will get a reward RT and he will move to a state ST plus 1. For example, if you are performing well in your exams, you will be promoted to a very good college. You will be rewarded, and your environment itself is changing, your state is changing. In the same way, that's what in the same way you can compare it with agent as well. So it's simple. The agent takes action based on the environment, and if the agent is attaining its goals, the agent is rewarded and moved to a new state ST plus 1, and the same process continues. This is a cyclic process. This will continue again. It's a cyclic process. But if he is failing, he will remain in the same state ST and he will be punished. If you see the practical applications, if you want to understand the practical applications of reinforcement learning, the practical applications are there. So the practical applications of reinforcement learning are, one best example I can give you is the robotics, then health and medicine, economics, chemistry, finance. All these areas we use reinforcement machine learning. So these are all the practical applications of reinforcement machine learning. Now I am going to discuss about some of the important terms we use. I was already using what is an agent, what is an environment, state, all these terms, reward. So I am going to define all these terms perfectly so that you will understand what is agent. So we discussed reinforcement learning is a type of machine learning where an agent learns to behave in an environment by performing actions and seeing the results. Here, the agent learned from the experience in the environment. The experience is, from the experience only the agent is learning, not from the training data set. That is very important. The agent, so now I am going to define what is agent. So agent means the reinforcement learning algorithm, the RL algorithm that learns from trial and error. We call it as agent. Agent means the reinforcement learning algorithm. We call it as the agent. It's the simplest definition we can give. So what is an agent? The reinforcement learning algorithm that learns from trial and error. We call it as an agent. Now, what is an environment? The world through which the agent moves. That is an environment. Environment, that is the next term you need to understand. It is the world through which the agent moves. So this is the first term you need to understand. This is the second one, environment. Environment is the world through which the agent moves. Now action, the third term you need to understand is the action. We already used these terms in our discussion. Next is action. So action means all possible steps the agent can take. What are all the possible steps the agent can take? That is action. That is action. Next term we are going to discuss is the state. That is very important. State. It is denoted by the letter S. Agent is denoted by the letter A, and reward is denoted by the letter capital R. So state means the current condition returned by the environment. It is the current condition. Current condition returned by the environment. That is known as the state S. Next is what is reward? So reward means, next term you need to understand is a reward. It is denoted by the letter capital R, reward. So an instant return from the environment to appraise the last action, that we call it as the reward. An instant return, it is a return from the environment. An instant return, reward or return from the environment to appraise the last action, that we call it as the reward. Another important term, we call it as policy. Policy, it is denoted by the Greek letter pi. This is really important. See, when we consider human beings as well, we are agents in our real life. See, some of the humans, we call it as visionaries. They think of the future and act. All right. So we call them as visionaries, or they are more creative. In the same way, the agent can also be a visionary. See, what I am telling is the agent can also be a visionary. Here, the most important thing you need to understand is the reinforcement learning can be understood easily by comparing it with real life. See, the policy, when you discuss about policy, our agent, the reinforcement learning algorithm, is a visionary. That means the approach that the agent uses to determine the next action based on the current state. See, that is, we call it as the policy. See, policy means the approach that the agent used to determine the next action based on the current state, that we call it as the policy. So what is policy? Policy is the approach that the agent uses to determine the next action based on the current state. See, based on the current state, what is the action I can take? So that is defined by policy. Now, next term you need to understand is value. That is the next term you need to understand. It is represented by the letter V. This is the important thing when you talk about policy or value, especially value. Here only that I told you, the agent must be a visionary. Here it comes into picture. See, visionary means value, how we are defining is the expected long-term return with discount as opposed to the short-term reward. See, if the agent is focusing on long-term return, that is, if the agent is focusing on future rewards, not only the current reward, if the agent is focusing on future rewards as well, then means the agent is a visionary. Such type of agents, we define the function value. So value, the expected long-term return with discount as opposed to the short-term reward R. So for if the agent is a visionary, he will focus on future, he will focus on not only the current reward, he will focus on the future reward, with discount. Such cases, for such agents, we will define the function value, or it is represented by V. Next term you need to understand here is action value. It is somewhat similar to Q. So it is action value Q. This is similar to value I told the previous term, except it takes an extra parameter, the current action. So it takes an extra parameter, the current action as well. So action value Q is similar to value V, except it takes an extra parameter, the current action A as well. So that is another important term, action value. Now one more term you need to understand here is the discount factor. See, discount factor, it is you may be familiar with this term. It is like you have the learning rate. See, in supervised machine learning, you might have learned the learning rate. See, in gradient descent algorithm, learning rate, it is the size of the baby step you use to optimize the cost function. So that we call it as the learning rate. Its minimum value is 0 and its maximum value is 1. This, discount factor, what we are discussing is somewhat similar to, it's not, the same thing, I can tell you, but you can compare it and learn. That's why I am telling, you to compare it and learn. See, I already told that you can use, in supervised machine learning, you use training data set. Here the agent learns by experience. So we can compare it and learn. In the same way, you have the discount factor here. Discount factor, it is represented by the letter gamma. Learning rate, it is represented by alpha in gradient descent algorithm. Here we use the letter gamma. See, discount factor, its value also, it ranges between 0 and 1. It is element of 0 and 1. Gamma, its value is between 0 and 1. See, if the agent is only focusing on the present reward, then gamma is 0. If the agent is not a visionary, then gamma is 0. If the agent is a visionary and he is focusing on the future rewards as well, then gamma is 1. This is the difference. So the value of gamma discount factor ranges between 0 and 1. If the reinforcement algorithm, if the agent it's not a visionary, the value of gamma will be minimum and it is 0. If he is a visionary, if he is focusing on future rewards more, the gamma increases and it can reaches 1, the maximum value 1. This is another important term you need to understand, that is discount factor. In the case of reinforcement learning, you can compare it with learning rate and gradient descent algorithm and learn it. And another thing is the reward. We already discussed a reward function. If the agent is attaining goals, he will be rewarded, and if he is not attaining, he will be punished. So based on that, we will define the reward. So that also we discussed. Now another point I want to tell you is about I already told in normally in machine learning, supervised machine learning, we usually define the cause function or loss function or objective function or error function or the same thing. So we always try to minimize this cause function. That's what we do. But the corresponding term comes into picture here is the reward or return. This is very important. Reward or return. Here we try to maximize the reward or return, but in the case of cost function we will try to minimize it. That is the difference. We will try to maximize the reward because the agent needs more reward than only so we call it as reward maximization theory. It states that a reinforcement learning agent must be trained in such a way that he takes the best action so that the reward is maximum. There is a theory also there, that is reward maximization theory. That's fine. You can understand like the corresponding term, like cost function. Here we have reward or return. So that is, we have to maximize the reward. If the agent is focusing on the current rewards, the discount factor is 0, that is gamma. And if the agent is a visionary and he is focusing on future rewards as well, the gamma will increase and it can reach up to 1. 1 is the maximum value. And the cost function, we usually define it as mean, absolute error, R root mean square value, different types. You define cost function as sigma n is equal to 0 to infinity y dash minus y the whole square, like that. You define cost function, you have a formula for this. This is the predicted value and this is the target value. You take the difference and square it. This is cost function. In the same way, you need to understand a formula for the reward or return. This is the Markov's reward theory. This is from the Markov's process. What we call it as the what we call it as, sorry, I just forgot. It is you have the Markov's decision process. See, this is from the Markov's decision process. You have the formula for this Markov's decision process. So why we come into this decision? Because in reinforcement learning, the most important thing is the decision, how the agent takes the decision and act on the environment. So here the most important thing is the decision in reinforcement learning. What type of decision the agent is taking when he is opened up, when he is exposed to an environment, because it is a complete black box. The environment is a complete black box for the agent. So what type of action he will take, that is really important. So Markov's decision process, in the same way you have the Markov's reward process, you have the Markov's reward process. I have a separate video for Markov's decision process. You can watch that video in the playlist. It's there in reinforcement learning. So from the Markov's reward process, you can understand the formula for the, reward or return. So I am writing the formula for reward or return. It is, you can write it as sigma t is equal to 0 to infinity. Gamma is the discount factor, gamma raised to t. R is the reward function. It depends on two factors, the current state and the current action. This is the formula for reward or return is equal to sigma t is equal to 0 to infinity. Gamma raised to t, gamma is the discount factor. R is the reward function. It depends on two parameters, the state, xt is the current state, it is the current action. So this is the, like this. So this is the formula for reward or return. In integral form, you can write it as, you can write reward or return equal to, in integral form, return is equal to integral of t is equal to 0 to infinity, gamma raised to t, r of xt, comma, reward function. It depends on the current state and action dt. This is in the integral form. So this is the Markov's reward process. This is the equation. You can get it from the Markov's reward process. This is the equation, not similar. You can compare like cost function. Here you have reward. So you need to maximize the reward. You need to minimize the cost function. So that is another important point. See, I have already defined, agent and the environment. See, one more very interesting definition I can give you. I have drawn that figure. You know it. You have the agent, environment, all these things. I already told you. Environment is a black box for the agent. All right. So in the same way, you can define environment as, environment is a function, mathematical function, which transforms action into a new state and a reward. See, you can see this figure. This is the agent. Here you have the environment. Here the agent do an action, right? AT. Then he may be rewarded and he will move to a state st plus 1. He can fail as well. Then he will be in the same state st. So this is the figure. So from this figure you can define environment is a function. It's a black box for agent. I am defining it as a mathematical function. This is another interesting definition. Environment is a mathematical function which transforms action, this action, which transforms this action into a new state and a reward, into a new state and a reward. That is environment. For the environment, input is an action and the output is a new state and a reward. So we can tell environment is a function which transforms action into a new state and a reward. In the same way, agent is a function which transforms a state and a reward to a new action. So when you are getting into a new state, see, you got promotion. After you got promotion and reward, after that you are into a new state and your action will be different. See, once you are promoted, your roles and responsibilities will change even in your company. In the same way, agent is a function which transforms the state and a reward to a new action. Then the roles and responsibilities of the agent will change. So very interesting definition. In this is a mathematical treatment for this agent and environment. So once again I am telling, environment is a function which transforms action into a new state and a reward, and agent is a function which transforms a state and a reward to a new action. Very interesting definitions. So this is about a very light introduction for reinforcement learning. So once again I need to summarize here. The most important thing is the decision. The agent, our reinforcement learning algorithm, how he is taking the decision and how he is acting and how he is learning by trial and error. So this is very important. Here we don't have any training data set. How the agent learns from the experience, that's also very important. See how a baby, how a baby is learning to walk. See, we know the baby will fall down around 400 to 500 times before it before the baby get up and start. It keep on trial and error, and finally the baby is attaining the goal. In the same way, the agent also in his environment, he is attaining the goals by trial and error. So it's a interesting part. So here 4 decision how making, we will use the Markov's decision process. That is another thing you can remember, Markov's decision process. So that thing we will cover in the next video. Markov's decision process will be there in the next video. Thanks for watching.